This is the 10th assignment in test prep, radicals and fractional exponents. So the big thing here is some conversion between rational exponents and radicals back and forth, and then just squaring both sides to remove radical signs. So here's a problem. Checking for extraneous roots, of course. Here's a substitution problem. This is all the no calculator on this page. So here you got to get a base of 2 everywhere to make this work. And this is a little bit of work. So 2 cubed squared, 2 cubed cubed, 2 cubed to the x. So 8 is 2 cubed. And then you got to do power to a power where you multiply the exponents and then you add here and that equals y. And then to make things worse, they don't even say y equals 3x plus 15. You have to take that and solve for x. A really hard problem there, that's for sure. Here, multiply both sides by the square root of x minus 2. Another multiplying to eliminate denominators. And then square both sides and solve out for x. So there's that squaring of both sides to solve for x. Here's another one where you're squaring both sides. Again, a little work because you got to square 16 to get it. Okay, another squaring both sides to remove the square root. And what happens is that negative 4 is extraneous in this because it does not make a true answer up here. 2 does. 2 makes a true answer. I'm sorry, 1 does. Excuse me. You get 2 equals the square root of 4, which is 2. 1 works, but negative 4 does not work because it gives negative 3 on this side and 3 on this side. Square root of 9, 5 minus negative 4. So negative 4 is extraneous. It doesn't work. And so we want the absolute value of that extraneous root. Extraneous just means extra. So square both sides. So 2 to the 6th is 64. So z must be negative 2. And again, you need to know that. 8 times 8, so 2 to the 3rd times 2 to the 3rd is 64. Another kind of hard problem there. Okay, square both sides, and then what is b? So you solve for b by dividing both sides by 3c. And you get b squared over 3c. A really good SAT problem right there. Okay, number 9, square both sides, lift the radicals, and then solve for k. Okay, you got to do a little common like terms here. Or I'm sorry, add a to both sides. I'm not thinking here. Ka equals 3a, and then divide both sides by a. A little bit of, you could just substitute in too. So 3, square root of 2a, square root of 2a. There you go. Just try the guess and check method. That works so often. Number 10, multiply the bottom. So what makes this true? Negative 5 squared is 25 minus 5 is 20. 5 will not work. 5 will work, excuse me, but it's not an answer choice. Okay, so flip these around. 100 to the q divided by 100 to the p equals 100 to the first. So make everything a base of 100. So q minus p must be 1. If you know this, the only way to get this is that q minus p, the difference in these exponents must be 1. Therefore, p minus q must be a negative 1 when you work it through. Okay, here, so p to the negative x would equal p squared because you divide both sides by p squared right here. And so p to the x would equal p to the minus 2. So you just throw a negative through each, take the reciprocal of both sides, I guess. And then q to the y would equal q to the 8th if you divide both sides by q to the minus 2. Be real careful. 6 minus negative 2 is q to the 8th. So that's what p to the x and q to the y is. So x plus y is negative 2 plus 8. which is 6. That's a little bit crazy of a problem. These are good, very good practice problems for um, what you will get. Add the exponents here, so z must be 0. Cube root of each, squared and 5. So it's like what times what times what is a to the 6? A squared. What times what times what is b to the 15th? B to the 5th. And now, how do you get a squared b squared? By dividing both sides by b to the 3rd. And that produces a 1 on this side and then an a squared b squared on the left. Problem 15, take each side to the reciprocal power. So this becomes 2 when you multiply to the negative 2. And so a is 1/4. Because 2 to the negative 2 means 1 over 2 squared, which is 1/4. So another really good problem that's on the no calculator part that's testing your ability. All right, so here you're just solving for t. This is the calculator part now. You put all of this in. When you, after 500 meters, how many seconds has gone by, and then you crunch it out. You divide it and take the square root, and you get 10.1. When you substitute all of that in, solve, isolate t squared, and take the square root, you get 10.1. 17 is a little bit awkward of a problem, but you start out this way. And solving for m. And so let m1 have a velocity of 1, m2 have a velocity of 2, let e be 1. And so you get this, where m1 is 2 and m2 is 1/2. And then, so their ratio is 4. All right, so what I wasn't seeing, I needed to write this down. It says it here. So if m1 has a velocity of 1, so v is 1 and e is 1, so that means it's 2. The value would be 2. I'm leaving the units out. If m2 has a velocity of 2, when e is 1, that means that v has to be 2, because you need 2 over 4 to make the 1/2. So then you divide the 2 out. 2 over 1/2 is 4. And that is assignment 10, taking us through these practice modules for test prep.